2026 A-Level Physics Paper 1, questions 11 up to 20. If you are interested in any of the other questions from question 1 up to 10 or question 21 up to 50, then check out the links in description down below. Now moving on to the first question, question 11 says, a monochromatic ray of light is incident on a glass block at an incident angle of 60 degrees. If the partially reflected and refracted rays are perpendicular to each other, what is the refractive index of the glass? Now to understand what's happening here, let's draw a quick diagram of the situation. So we have a glass block and we have a ray of light incident at 60 degrees to that glass block. Now what this means is that if we draw perpendicular here at the incident point, the angle between the perpendicular and the ray of light, which is this angle right here, is equal to 60 degrees. Now given that if this angle is 90 degrees and this is perpendicular, the other angle here will be equal to 30 degrees. Now the two rays they're talking about here are the partially reflected rays and the refracted rays. If we first consider the partially reflected rays, the partially reflected rays will look like this, where the angle between themselves and the surface of the glass block will be exactly the same as the angle between the incident ray and the glass block. So therefore, if this angle is 30 degrees, the angle here will also be 30 degrees. Now the second ray they're talking about is the refracted ray, and this ray is said to be perpendicular to the original reflected ray. So therefore, the refracted ray will go like this, such that the angle in between these two rays will be 90 degrees. Now if the angle here is 90 degrees, we can see if this angle is 30 degrees, the remaining angle, which is this angle, must be equal to 60 degrees. Now furthermore, since this angle is also 90 degrees, the angle in between the perpendicular and the refracted ray must be equal to 30 degrees. Now according to this, the incident angle is 60 degrees, so I is 60 degrees, and the refracted angle R is equal to 30 degrees. Now from this, what we have to do is to directly apply Snell's law and say the refractive index of the glass is equal to sine I by sine R, which is equal to sine 60 by sine 30, and sine 60 is equal to root 3 over 2, and sine 30 is equal to 1 over 2, and dividing these two we can see the 1 over 2 and 1 over 2 here cancel, leaving us with root 3, and therefore the refractive index is equal to root 3. So the final answer here is root 3. Now fun fact, in physics there is actually a separate formula that is related to this specific phenomenon. It is called Brewster's formula. It says that if you have an incident angle of I and your reflected ray and refracted ray are perpendicular to each other, then the refractive index of your medium is equal to the tangent of the incident angle. Now applying the distribution, we can see we would have gotten n equals tangent of 60 degrees, which is in fact equal to root 3. Now while this is correct, it is not within our syllabus, so you are not expected to use it. However, within the MCQs, you can use it. Now anyway, moving on to the next question, question number 12 says, how much water should be filled in a cylindrical container of 20 centimeters in height so that it appears half filled when viewed from the top of the container? And they say the refractive index of water is 4 over 3. Now considering the situation here, we can see we have a cylinder like this of total height of 21 centimeters, and inside of it we are expected to fill a certain amount of water, let's say h amount of water, such that when the water has its apparent depth changed and the apparent floor of the container moves up, this apparent height and the height of air remaining above the water are both equal to each other, because then the glass will appear to be half full. Now according to that, if we consider the height of air will say, let's say h air, not here, h air is equal to 21 centimeters minus h. Now considering that, we want the apparent depth, let's say d, of this water to be equal to 21 minus h. Now considering the apparent depth, we know that the apparent depth is equal to the real depth of h divided by the refractive index. So d is equal to h divided by 4 over 3, which is equal to 3h over 4. Now according to this, if we want this to look half full, the height of air and the apparent depth should both be equal to each other. So therefore we can say h sub air, not here, h sub air must be equal to d, which gives us 21 minus h equal 3h over 4. And simplifying, we can see if we take this 4 to this side, we have 84 minus 4h equals 3h, which uses 84 equals 7h, and therefore h equals 84 divided by 7, which is equal to 12 centimeters. So therefore, the depth of the water must be equal to 12 centimeters. Now what happens here is that the depth of the water is equal to 12 centimeters, and therefore the area above it is equal to 9 centimeters, and therefore when this 12 centimeter turns into 9 centimeters based on the apparent depth, we get 9 centimeters of apparent water and 9 centimeters of air, and therefore the glass appears half full. So when someone asks you, is the glass half full or half empty, you have to say it is actually 9/21 or 3/7 empty and 12/21 or 4/7 full. It is not half empty or half full. It's not half empty or half full. It is instead 3/7 empty and 4/7 full. Now anyway, moving on to the next question. Question number 13 says, if the mass of a radioactive sample is increased, the activity and the decay constant of the sample are respectively what? Now activity here is equal to the number of decays that occur per second. Due to that, if you have a small sample, the number of decays that occur is small, but if you have a bigger sample, the number of decays that occur is larger, since the number of decays that occur per second is proportional to the mass of the sample. So therefore, the first one should be increases. The activity increases. Now instead of this said, the activity per unit mass of something, it will remain constant. It's only the activity that increases. The activity per unit mass or activity divided by mass of both of these is still the same. So out of the answers, it could be 1, 5 or 4. Now considering the other one is the decay constant of the sample. Now the decay constant of a sample is a constant for a given radioactive material. Due to that, if we have the same radioactive material and we increase its size, the decay constant will remain the same. So therefore, for question number 13, the answer is answer number 1, increases and remains the same. Now moving on to question number 14. Question number 14 says, a child holding 2 weights in his hands is sitting on a chair with folded hands on a platform that is rotating about its central axis. So the child is sitting with the hands bent inward like this and rotating about some kind of central axis. Now given this, they say the rotational kinetic energy RKE of the system is equal to K. They also say if the child stretches his arms so that the moment of inertia system doubles, what is the rotational kinetic energy, or they should say final rotational kinetic energy of the system. Now to understand this, let's consider the initial and final situations. So in the initial situation, the child is sitting down on a chair on a platform and rotating with their arms bent inward like this. Now given this, let's suppose that the initial angular velocity is equal to omega1 and the initial moment of inertia is equal to I1. Given that, the initial rotational kinetic energy K will be equal to half I1 omega1 squared. Now from this, what happens is that the child stretches their arms outward like this, and when that happens, the moment of inertia doubles. So therefore the moment of inertia here is I2, then I2 will be equal to 2I1. Now given this, let's suppose its angular velocity is omega2. Now given this, since we must have conservation of angular momentum here, we must have I1 omega1 being equal to I2 omega2. And rearranging, we can see if we substitute I2 equals 2I1, we get I1 omega1 equals 2I1 omega2. Cancelling this one, we get omega1 equals 2 omega2, and therefore omega2 is equal to omega1 divided by 2. Now considering this, if we consider the final rotational kinetic energy RKE, we're going to get half I2 omega2 squared, which is going to be equal to 1/2 times I2, which is 2I1, times omega2, which is going to be equal to omega1 divided by 2 squared. And simplifying, we can see we get 1/2 times 2 times, and then from this 1/2 squared we get 1/4 times I1 times omega1 squared. Now here, this 1/2 times omega1 squared times I1 can be taken as K. So here we have K. So here we have 2 times 1/4 times K, and cancelling these two, you can see we get 1/2K. So therefore, the final rotational kinetic energy here is equal to 1 over 2k or k over 2. So the final answer here is k over 2. Now moving on to question number 15. Question number 15 says, an electric generator in construction site produces sound intensity level of 50 decibels at a certain point. It then says, due to the operation of another equipment, the sound intensity level at that point becomes 100 times the original value. So this means that the machinery we are using is extremely loud. Now given that they ask us what is the new sound intensity level at that point. Now to answer this question, we need to know that decibels are logarithmic. A reading in decibels is equal to 10 times the logarithm base 10 of the intensity divided by I0, where I0 is the smallest sound intensity that can be heard by the human ear, which is equal to approximately 10 to the minus 12 watts per meter squared. Now to answer this question, we need to understand that 50 decibels here corresponds to 10 times the logarithm base 10 of some initial intensity divided by I0, and when we use this other equipment, it becomes 100 times, and therefore our new intensity, let's say I dash decibels, is equal to 10 times the logarithm base 10 of the new intensity of 100 times I divided by I0. Now in order to answer this, what we need to do is to realize that when you have logarithm of, let's say, A times B by log rules, this will turn into log A plus log B. Now according to that, if we have 100 times I divided by I0, we can rewrite this as being equal to 10 times log base 10 of 100 plus log base 10 of I divided by I0. Now in this case, if 50 is equal to 10 times log base 10 of I divided by I0, then we can see dividing by 10, log base 10 of I divided by I0 is equal to 5. So therefore here we get 10 times, this bit is going to be equal to 5 plus the log base 10 of 100. And log base 10 of 100 is simply equal to 2. So therefore we get 10 times 2 plus 5, which is equal to 7, and 7 times 10 is equal to 70. So therefore the final intensity here is 70 decibels. Now as a shortcut, what you can do is to realize that an increase of 10 decibels is correspondent with a multiplication of 10 on intensity. So if you have 20 decibels, which is 2 tens, that is going to be correspondent with a multiplication of 2 tens or a multiplication of 100. Now similarly, if you have a subtraction of 10 decibels, it's going to be equal to a division of 10, and therefore if you have subtraction of, let's say, 30 decibels, that is equal to a division of 10 by 3 times or a division of 1000. Now with that, we are done with question number 15. Next, if we consider question number 16, question number 16 says, a compound microscope and an astronomical telescope are in normal adjustment positions. If the focal length of both objective lenses of both of these is increased, what will happen to the magnifying power of the microscope and the telescope respectively? Now the correct answer here is answer number 2, decreases and increases. To understand why, while I will not be explaining exactly how these two equations are derived, I will show you two equations and show what happens when FO, the objective lens focal length, increases. Now the first equation is the equation for the magnifying power of microscope, which is going to be m sub micro, which is approximately equal to L times D divided by FO times FE when our microscope is in normal adjustment. Now here, L is equal to the distance between the two lenses, D is the near point, which is about 25 centimeters, FO is the focal length objective, and FE is the focal length eyepiece. Now here we can see when FO is increased, since it is on the denominator, M will decrease, and therefore for the microscope, the magnifying power will decrease. So the answer could be this or this. Now the other equation relevant is the equation of magnification of a telescope, or M-tele, which is approximately equal to FO divided by FE in normal adjustment. Now here we can see when FO increases in this one, magnification is also going to increase, and therefore for the telescope, our magnifying power will increase when the focal length of the objective is increased. So the answer is decreases and increases, which is answer number 2. Now next we consider 17. 17 says, an inflated helium air balloon has a volume of 500 cubic meters. Given this, what is the largest mass that can be raised upward by the balloon? And for this we are told to neglect the mass of the material of the balloon, and also told the densities of air and helium are 1.28 kilogram per cubic meter and 0.18 kilogram per cubic meter respectively. Now for this we need to understand that the upward buoyancy is going to be given by beta times V times G, where beta here is the density of the surrounding air. So that's going to be equal to 1.28 kilograms per cubic meter times 500 meters cubed times 10 meter per second squared. And the downward force due to gravity on the weight of the helium here is going to be equal to rho Vg, where rho is equal to density of helium. That's going to be 0.18 kilogram per cubic meter times 500 meters cubed times 10 meter per second squared. Now, out of these two, if we consider total force, the total upward force is going to be equal to the difference of the upward force due to buoyancy minus the downward force due to gravity, which is going to be equal to 1.28 minus 0.18 times all of this, which is equal to 1.1 kilogram per cubic meter times 500 cubic meters times 10 meter per second. Now, if this upward force is going to lift up a certain mass, it's going to have to be equal to m times g, and therefore it's going to have to be equal to m times 10 meters per second squared. Now here we can see if we divide this 10 by this 10, we get m being equal to 1.1 kilogram per cubic meter times 500 cubic meters, and therefore the maximum mass we can lift is equal to 1.1 times 500 or 550 kilograms. So therefore the final answer here, the maximum mass that our balloon can lift upward is equal to 550 kilograms, or answer number 2. Now moving on to question number 18. Question number 18 says, an ideal gas expands from a lower volume to a higher volume by different thermodynamic processes. And given this, we are asked to consider the following statements. Now statement A says, the amount of work done by the gas is maximum when the expansion is isobaric, and isobaric means constant pressure. Statement B says, the heat absorbed by the gas is maximum when the expansion is adiabatic. Now this statement is immediately wrong because adiabatic means that there is zero heat absorbed. Delta Q is equal to 0. So therefore we can see immediately, since they said that the heat absorbed is maximum but the heat absorbed is actually 0, statement B is immediately wrong. Now similarly, if we look at statement C says the change in internal energy of the gas is maximum when the expansion is isothermal, and isothermal means that the change of temperature is equal to 0, or the temperature is constant. Now according to that, since delta U, the change of internal energy, is proportional to delta T, the change of temperature, and since change of temperature delta T is equal to 0, change of internal energy is also equal to 0, and therefore it cannot be maximum. So therefore statement C is also wrong. Now since B and C are already wrong, we can see immediately the correct answer is only A. But rather than just writing this as only A, let's see exactly why statement A is correct. Now if we consider isobaric expansion and consider this graph right here, we can see if we expand from low volume V1 up to high volume V2 at constant pressure as in isobaric expansion, the expansion will look like this. Starting from the initial pressure of P1, if we go forward and keep that same constant pressure, then at the first point we'll have V1 P1, and at the second point we will have the same pressure of P1 but new volume of V2 which is bigger than V1. So therefore isobaric expansion looks like this. This is isobaric expansion. Now the important thing to note is that any other kind of expansion other than isobaric expansion will have us ending up at a lower pressure than the original pressure P1. If we consider, for example, isothermal expansion, since the temperature is constant and this is an ideal gas, P1 V1 will be equal to P2 V2, and according to that the graph will go down like this, such that if we have the final pressure here at the volume V2 and this pressure here is P2, then P1 V1 will be equal to P2 V2. Now similarly, if we consider another expansion, let's say adiabatic expansion, let's just mark this first isothermal expansion. And if we then consider adiabatic expansion, it will also go down like this and reach a point of V2 where the pressure is lower than the pressure here of P1. Now due to this, since all of these other thermal expansions will reach a lower point, adiabatic, will reach a lower point than isobaric expansion, and since the total area under each of these PV curves is equal to the work done, we can see since the area under isobaric expansion is maximum, the work done will also be maximum for isobaric expansion. Therefore, A is correct, B is wrong and C is wrong, giving only 1 as the correct answer. Only A is true. Now moving on to the next question, question 19 says, the velocity versus time graph of a particle is shown in the figure. Given this, what is the net displacement of the particle? Now here, the net displacement is equal to the net area under the curve, in between the curve and the x-axis. And here we can see that will be equal to this area plus this area minus this area, since this area is under the curve and is therefore negative. Now considering that the first area here is a triangle with base of 2 and height of 6, and that is equal to half into base into height, or half into 2 into 6, or 6 meters. The next area is again a triangle with height of 6 and base length of 2, and therefore it's also going to have half into base into height, or half into 2 into 6, or 6 meters of area under it. Now for the last triangle, this triangle is again base 2, height 6, but is negative 6, so the area here is equal to half into 2 into negative 6, or negative 6 meters. And adding these together, we can see the negative 6 and 6 cancel, leaving us with only 6, and therefore the answer here is equal to answer number 3, 6 meters. Now finally, if we go to question 20 says, what is the reading of the ammeter shown in this circuit? Now while this question looks complicated, it's actually asking us what is the current flowing across this ammeter from this point to this point. Now to solve this, all you need to do is to realize that if we consider these two resistors, the ratio of these two resistors here is 6 to 4, or 3 to 2. And if we consider these two resistors, the ratio here is also 12 to 8, or again 3 to 2. Now since these two resistor ratios are 3 to 2, and from this point to this point the voltage across both of these pairs is 20 volts, this is going to create a Wheatstone bridge. And in this Wheatstone bridge, since these two to these two's ratio are the same, we can conclude that the voltage at this point and this point are both equal to each other. So the voltage here is V1, the voltage here is also V1. Now according to that, since the total potential difference across A is equal to 0 here, we can conclude that no current will flow across the ammeter A. And therefore, the answer is answer number 1, 0 amperes. And with that, we are done with the questions from 11 up to 20. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching, and goodbye.